Hey everybody, it's Basora back with you for your Algebra 2 section today is on compound inequalities and absolute value inequalities. So let's dive right in. This one's going to be a little longer today, so hopefully you've got some time to sit down. This will take us about 15 minutes or so. So when we talk about compound inequalities, we have to remember a couple of things. When we do absolute values and inequalities combined into one problem, we separate between less than or equal to's are our and problems, or less than problems, I should say, and greater than or equal to or simply greater than are our or problems. So these will work just like our inequality problems that we've seen in the past. So what we're going to do with and problems is we are going to turn them into compound inequalities. So we're going to take this one right here for number 1. We have the absolute value of r is less than or equal to 2. So we're going to take the absolute value bars off. And on the other side of this, of the variable here, we're going to put another less than or equal to create our compound inequality. And we're going to take the number from the right side and we're going to put the negative version onto the left side. This is going to create a new equation that in some cases we'll have to solve, but in this particular case, it's solved for us. So at -2, we have a closed circle because at -2, it's less than or equal to. And at +2, we also have a closed circle and we shade in between for the ands. Now for the ors, remember ors, we have to have 2 separate cases. So what we're going to do is we'll start with the original equation. V is greater than or equal to 5. That one's already ready to graph. And then what we're going to do is we're going to do the opposite of our absolute value is greater than or equal to 5. Now this involves us doing a little bit of solving, which means we're going to have to do the dividing by the -1. Well, if we divide by the negative, we have to flip our absolute value sign. So we have v is less than or equal to -5. So with the or cases, you need to split it and change the second case to have a negative in front of whatever was inside the absolute value. So this means I'm going to graph v is greater than or equal to a +5. So closed circle at 5 and greater than or equal to. And then at -5, another closed circle and less than or equal to. So you'll see with or problems, we're going to get with greater than problems, we'll get our or situation. And with less than problems, we will get our and situation. Let's look at some that have a little more involvement in them. So in number 3, so we have a greater than, which means we need to do our split cases. So we have we have x plus 5 is greater than 6. And then our other case is going to be the opposite of x plus 5 is greater than 6. Well, the first case is easy to solve. We just subtract 5 from both sides. So we end up with x is greater than 1. Now in this case, you could choose to distribute. You could choose to divide by the negative right off the bat. So let's do that first. Let's divide both sides by the negative. So that means we would get x plus 5 is less than -6. And we'd finish solving by subtracting 5 on both sides, which would leave us with x is less than -11. Now we have our ors to graph. So -11, open circle, because it's less than, not less than or equal to, and less than. We've got x is greater than 1. Oops, +1. So let's do open circle at 1 and go greater than. Let's change up because we're running close to each other here. Now, in this case, we have a less than. The less than is our ands. So take what's in your absolute value, drop the absolute values, but because it's less than, we're going to put another less than sign on this side and put a negative of what the solution was on that side. Well, now in order to solve this, how do we get a by itself? We divide everything by -8. This is our compound inequality solving. So remember, now we divided by the negative, we're going to have to flip all these signs around. So -16 divided by -8 is +2 is greater than. A is greater than 16 divided by -8 is -2. And now in order to graph this, we need to flip the whole thing around. So -2 is less than A is less than +2. So our final solution to this, we're going to have an open circle at -2, an open circle at +2, and we shade in between. All right, on to our next cases. Again, each time we're going to take this up just a small piece every time. All right, we've got another less than case, so we can do that. But before we do that, we need to isolate the absolute value. That rule has not changed about absolute values. So the first thing I want to do with 6 plus the absolute value of -8 plus x is less than or equal to 16. Before I can do the compound inequality, I need to isolate the absolute value by itself. So let's subtract the 6 from both sides. That'll leave me with the absolute value of 8 plus x is less than or equal to 10. Now we can drop our absolute value bar. So 8 plus x is less than or equal to 10. On the other side, we'll add another less than or equal to and put in our -10. Subtract 8 on both sides, on both ends, I should say. It will cancel out in the middle. Well, -10 minus 8 is -18 is less than or equal to x is less than or equal to 2. And somewhere I have missed a sign. Okay, guys, I found where it was. So I had to pause my recording real quick. So I found out, I looked at what I did, and this is likely that everybody will make these mistakes, so it's good for you to see me do it. So I've got a -8 here, but all of a sudden I dropped that and made that a +8. So I'm going to take all of this out. My apologies, it's going to make this video slightly longer, but we'll make up the time at another point. So let's go back and put in our negative where it was supposed to be. So if we have -8 plus x is less than or equal to 10, we still want to put our less than or equal to -10 on this side. But then when we go to add 8 to both sides, we'll have to add 8 instead of subtract 8. So we ended up with numbers kind of flip-flopped here. That gives us -2 is less than or equal to x is less than or equal to 18. So now I know that I'm going to put a closed circle at -2, a closed circle at +18, and we are going to shade everything in between. All right, let's take a look at our greater than. Again, we have an or situation here, but before we can do the or situation, we need to go ahead and isolate the absolute value. So this +7, I need to actually subtract 7 from both sides of this. So I'm looking at the absolute value of n minus 6. Take that off there. N minus 6 is greater than or equal to 4. I've got greater than, so we'll leave the first case, n minus 6 is greater than or equal to 4. And then on the other case, we'll have the negative of n minus 6 is greater than or equal to 4. So the first case is the quick one to solve. Add 6 to both sides. So you get n is greater than or equal to 10. On this one, I would suggest to divide by the negative and get rid of that first. Again, you can distribute if you choose to. So that's going to leave me with n minus 6 is less than or equal to -4. Now you'll notice every time we do this, all that happens is we switch the sign and we change the direction of our inequality. If you want to just get in that habit of doing that, you're welcome to do so. We're then going to add 6 to both sides, and we have n is less than or equal to 2. So I'm going to have a closed circle at 2 going less than. I'm going to have a closed circle at 10 going greater than, and I've got my or situation. All right, on to the next ones. We've got 4 or 6 more to take care of. Number 7. So number 7, the absolute value is already isolated, so we can go ahead and drop our absolute value sign. And on the other side of our inequality, we can put in the negative 43. Now we have 2 steps inside here. So let's go ahead and get rid of the 7 first. Let's add that to both sides, to both ends. So if I've got negative 43 plus 7, I've got negative 36 is less than or equal to 6r is less than or equal to 50. We then need to divide everything by 6. And this one's a little strange because you'll notice negative 36 divided by 6 is a nice whole number. The 6's cancel and leave r, but 50 doesn't divide by 6. So you might find yourself saying, I work better with decimals. You might work better with fractions. So whether you want to leave a fraction of 25 over 3, which would be the simplified fraction, or if you're a decimal person, 8.3, so you'll know where to plot your point. Either one is fine with me. So negative 6, we've got a closed circle at negative 6. We have a closed circle at 8.3, so we'll want to go somewhere in between 8 and 9, and we will shade everything in between. All right, let's take a look at number 8. We have a greater than, but the absolute value is already isolated. So 2 cases, negative 2b minus 3 is greater than or equal to 15. And if you want to do the shortcut of our situation for the second case, remember, keep what's inside. So negative 2b minus 3, switch the sign, change the sign. So switch sign, change signs. Now you've got your 2 cases. So we'll add 3 on the equation on the left. So we have negative 2b is greater than or equal to 18. Divide by negative 2. Don't forget, when you divide by the negative, your inequality will change, so it'll flip backwards. So we get b is less than or equal to negative 9. Work the other side out. We'll add 3 to both sides. So we get negative 2b is less than or equal to, well, negative 15 plus 3 is negative 12. We still have to divide by the negative, so it's going to flip one more time. So b is greater than or equal to 6. And we expected this to be an or situation, and it came out to be one. So we have a closed circle at 9, less than, and we have a closed circle at 6, and we have greater than. All right, we're down to our last 4 problems. All right, so we have a greater than situation, but we have this 5 being divided, the absolute value is being divided by 5. So before I can do my 2 cases, I need to multiply by this 5 to get rid of it. So now I have the absolute value of 6a plus 9 is greater than 5. So our 2 cases, 6a plus 9 is greater than 5, and 6a plus 9, flip it, change the sign, solve both cases. Subtract 9 on both sides. So 6a is greater than negative 4. Divide by 6, but 4 and 6, those aren't divisible into each other, but we can write it as a fraction, negative 2/3. Same thing on the other side. Let's subtract 9 on both sides here. We get 6a is less than negative 14. Divide by 6, divide by 6. This simplifies, but it does not divide evenly. So we get a is less than or equal to negative 7/3. Now, if you work better in decimals, okay, negative 2/3 will be someplace in between 0 and negative 1. So we're going to have an open circle here that's going greater than. And then negative 7/3 is approximately 2.3. So negative 2.3, open circle here, and less than. You shouldn't get too many that have the fractions in them. A lot of times on the number lines, we try to make them come out nice and even for you. But again, no guarantees when it comes to the numbers. All right, number 10. We're going to subtract this 8 before we do anything else. So then we have the absolute value of 7 plus 2k. I keep wanting to write parentheses. Is less than or equal to 7. So we can do 15 minus 8. Well, we have a less than. That means compound inequality. So 7 plus 2k less than or equal to 7. On the other side, less than or equal to negative 7. Subtract 7 on both sides. So we get negative 14 is less than or equal to 2k is less than or equal to 0. Divide everything by the 2 in front of your k. So we have negative 7 is less than or equal to k is less than or equal to 0. So at negative 7 and 0, we are going to have closed circles. And because it's a and problem, we're going to shade everything in between. Okay, so hang tight, guys. Last two problems, and then you are done. So here we go. We have a greater than, but we have to get rid of these other pieces. So before we even do our two split cases, let's look at what we need to take care of. So we have 7 times the absolute value of 8 minus n plus 4 is greater than 81. The first thing I want to do is move the 4. I want to get rid of this because that 7 is almost attached right to that absolute value. Can't deal with that just yet. So we have 7 times the absolute value of 8 minus n is greater than or equal to 77. Now we can divide by the 7. So we get the absolute value of 8 minus n is greater than 11. Now we can do our split cases. So 8 minus n is greater than 11, or 8 minus n is less than, flip it, change it. So now we can subtract 8. So we will end up with negative n is greater than 3. But we have the negative here, so we're going to have to flip it around into n is less than negative 3. There's my one case. Subtract the 8 on the other side. We get negative n is less than negative 19. Flip it around. So we will get n is greater than positive 19. This is an OR problem. So go to negative 3. In between here, we should have an open circle, open circle, go less than, go to 19, open circle, and greater than. All right, guys, to keep our video short, I'm going to go ahead and give you the solution for this final one, just so that you've got everything there that you're going to kind of need. So we will hold off on this. I'll do a separate video actually probably to cover this last problem. I think you have everything that you will need to cover these last pieces. Your homework tonight is going to cover the inequalities and graphs. It's 10 problems tonight. If you have any issues, you shouldn't run into too many of these longer problems. Most of them are going to be shorter along the lines of what you saw in here as far as problems, things like 7 and 8. So if you run into any trouble, by all means, send me a screenshot, ask questions, and we will see you guys on the next video. Thanks for watching.